Okay, in this lesson, you are going to learn to solve systems of equations by graphing. And what this essentially means is you're going to figure out how to solve for x and y's given two equations. And you're going to solve for x and y's through graphing. So let's go ahead and get started with the first example. Here we have two equations, y equals 1/2 x minus 2. And the second equation is y is equal to 3x minus 7. And the goal here is to figure out what x and y's are that satisfy both equations. And to do this, we're going to graph the equation of both lines and see what our answer is. Okay, so if we were to graph the first equation, y equals 1/2 x minus 2, since this is already in slope-intercept form, right, y equals mx plus b, we can go ahead and plot the y-intercept, which is going to be minus 2. So that's going to be down here. And then we see that our slope is 1/2, which means we're going to rise 1 and run to the right 2. So starting from here, we're going to rise 1 and then run to the right 2. We're going to draw a point there, and we'll just do another one. We're going to rise 1 from here, and run to the right 2. So we're going to plot another point there. Okay, and then we're going to go ahead and draw a straight line. Okay, and there we go. So this blue line represents y equals 1/2 x minus 2, and then we're going to go ahead and graph the other line, and we see that this is also in slope-intercept form, y equals mx plus b. So we'll go ahead and plot the y-intercept first, and since that is -7, we're going to plot a point at -7 on the y-axis. And we see that our slope is 3, so that will be a rise 3 and then run to the right 1. So starting from the point that we just plotted right here, we're going to rise 3, 1, 2, 3, and then run to the right 1. So we'll plot a point right there. And let's go ahead and do another rise over run. So from this point, we're going to rise 3, 1, 2, 3, and then run to the right 1. So it's going to land right there. Okay, and we go ahead and draw a straight line. And there you'll see that both the blue line and the green line intersect at this point right here. And since this point is 2, -1, let's go ahead and write that down. This is 2, -1. Then we know that our x is equal to 2 and our y is equal to -1. And this is our solution to these two equations, or to this system of equations. Okay, so in this example, we have one solution to this system. So let's move on to another example where we don't have one solution. So we have the following equations. We have a y minus 2x is equal to 6, and a -4x plus 2y is equal to 8. Let me go ahead and change those colors. Okay, so this first equation is not in slope-intercept form, so it's a little bit difficult to graph. So what we're going to do is change this into slope-intercept form. Okay, so I'm going to go ahead and write it to the right side over here. I'm going to just rewrite the equation. We have y minus 2x is equal to 6. Okay, what we can do is move this -2x over to the other side, And we can do that by adding 2x to both sides. And the result is y is equal to 2x plus 6. Okay, and then let's go ahead and resolve this other equation. This negative 4x plus 2y is equal to 8 is not in slope-intercept form either, so this is a little bit difficult to graph. And so we can rewrite this by making it into a slope-intercept form. And so what we're going to do is we're going to move this 4x to this side of the equation, and we do that by adding 4x to both sides. And when we do, we get 2y is equal to 4x plus 8. Okay, and then now we want to isolate this y. We don't want 2y. We want to make this just y. And to do that, we're going to divide both sides of the equation by 2. Okay, now watch. We're going to divide this side by 2, but this entire side also needs to be divided by 2. So we're going to divide it by 2, divide this by 2, and divide this by 2. And in doing so, we get y is equal to 2x plus 4. Okay, so let's go ahead and graph both of those equations. We're going to start with this blue one. Okay, we see that our y-intercept is a 6, so we're going to plot a point right here in blue. And we also see that the slope is a 2, so we're going to go ahead and plot that. So that'll be a point right here. Oops, let's redo that. We're going to plot a point right here. Okay, because we go up 2 and run to the right 1, and we can also go down 2 and run to the left 1. So we're going to plot a point there. Okay, and we're going to go ahead and draw a straight line. And there we have it. So next we're going to draw the equation of this line, the one that's in green. We see that our y-intercept is 4, so we're going to plot a point there. And we're also going to plot our next point by identifying the slope. In this case, it's 2. Okay, so we're going to start from the y-intercept. We're going to count up 2, 1, 2, over 1, 1, 2, over 1. So we're going to plot points there. 1 there, and 1 there. And then we're going to go ahead and draw a straight line. And there we have it. And what you notice is that both the blue and the green lines are parallel to each other, which means there is no intersection whatsoever. And when this happens, the answer becomes no solutions. No solution. Okay? So the key here is whenever you have parallel lines, and you know it's parallel because the slopes are the same. See that? 2x, 2x. When the slopes are the same, that means the lines are parallel, which is always going to result in no solution. So that's the key. Whenever you see parallel lines, regardless of the y-intercept, okay, these numbers could be anything. If these are exactly the same, the slopes are exactly the same, then it'll always be no solution. Okay, now let's move on to the third and last example. Okay, here we have two more equations. One is 15x plus 5y is equal to 25, and the other is y equals 5 minus x. Okay, this equation is not in slope-intercept form. Okay, so we're going to go ahead and move some numbers around so that it is in that form. So I'm going to go ahead and write it to the right side of the graph. I'm going to rewrite this as 15x plus 5y is equal to 25. Okay, what we're going to do first is we're going to move this 15x to this side of the equation, and we do that by subtracting 15x on both sides. And when we do, we get 5y is equal to negative 15x plus 25. Okay, so now we're going to divide both sides of the equation by 5. And when you do, we have to make sure that we divide 5 across every component. Okay, so we're going to divide this by 5, then we're going to divide this by 5, and then this by 5. So then what we would get is y is equal to negative 3x plus 5. Okay, now let's go ahead and move over to this green equation, y equals 5 minus 3x, and let's just rewrite this so that it is in slope-intercept form. And all we're going to do is move these around. Okay, when we do, we get y is equal to negative 3x plus 5. Okay, now take a look at this equation. Y equals negative 3x plus 5. This is the green one. And the blue one says the same thing. Y is equal to negative 3x plus 5. Those equations are exactly the same. We don't even need to graph, because when you have the same exact equation, the answer is going to be infinitely many solutions. Okay. Infinitely many solutions. Or we could say all solutions. Okay. What this means is any y, any x will make both equations valid. Okay? So these are the 3 different scenarios. The first example, where we graphed, we had one solution. The second example, where we graphed, the lines were parallel, so there were no solutions. And then this last example, where both lines are exactly the same, and we have infinitely many solutions or all solutions. Okay, hope that makes sense. If any of this was confusing, please go back to the beginning of this video and watch this again. Thank you.